All right, let's take a look at our lesson today. So today we're going to be finding limits algebraically. That's what we're going to be working on. So if you recall, last time we looked at finding limits graphically and numerically. I'm just going to run over here just to remind ourselves what we were doing. So if we're looking at it graphically, we were looking from the left and from the right. We were seeing whether we approach the same y value. Remember, the answer to a limit is the y value. Okay, the answer to a limit is the y value. So let's look at how we would work these algebraically. There's really only three things that can happen when we're doing a limit algebraically. So what we do is we substitute the x value into the limit expression. What do I mean by that? Okay, I'm talking about this x value right here. You know, the x goes to 3. This. So we'd put in a 3. Or we'd put in a 2. Whatever the number happens to be on our limit. So we substitute that value in. And the first thing that could happen is we could get like a number. Oh, that would be magical, right? We get like 5. Well, we're done. Now, I hate to say this is like, not that often that they give us a limit that we can simply just substitute in and we're done, unfortunately. So if that happens, great. The second thing that could happen when we substitute the number in is we could get a 0 over 0 or an infinity over infinity. We could get that. Okay, those are called indeterminate forms. Indeterminate forms. So thinking of the English word indeterminate, my students that are way better English than I am, what that word means, indeterminate. That means we can't figure it out, right? We don't know. That we don't know. So if that happens, we get a 0 over 0 or infinity, we should try. We try, I say we keep going. We keep going. Later, we will learn a technique called L'Hopital. We haven't learned that yet. If you know it, that is perfectly fine, but we're not going to use that yet. These 4 things, probably 95% of the times, the thing that you're going to do is one of these 4 things. So would it make sense to factor? We would factor it and then see if we could get it to be able to just substitute the number in and get an answer. That's what we're hoping for. We're hoping for, in doing one of these things, we'll bounce back to type 1 and we'll just be able to plug in a number and we're done. Okay, that's what we're hoping for. So what do we try? We want to try factoring. We would try multiplying by the conjugate over the conjugate, which is another way of saying a clever form of 1. We can only multiply by 1, by the way. We can't multiply by anything else. Like you're not allowed to square it or square root it. You're not allowed to do any of that stuff. You can only multiply by 1 when we're working with limits. We might need to fix a complex fraction. Long ago when you learned fractions and fixing complex fractions or fixing, making it workable, perhaps you remember the phrase keep, change, flip. You keep the numerator, you change division and multiplication, you flip the denominator. That's how we would fix a fraction. And the last thing, if we're working with trig integrals, we'll need trig properties. We'll need to be able to substitute, say we have sine, we might need to turn it into, 1 over cosecant, or maybe we have tangent, we might need to turn it into sine over cosine. We might need to do that. So that's what happens if we get 0 over 0. All right, the third thing that can happen is if you get a number over 0. Okay, let's say you get, 5 over 0. So if we get that, what that means is that we have a vertical asymptote at that location. That's what it means when we get a 5 over 0, negative 3 over 0, something like that. And our answer would be one of these scenarios, either infinity, negative infinity, or D and E. Okay. So I want to, let's see if we have, talk a little bit more about this. So let's say we do a limit and we get like, let's say we do the limit as x goes to 2 of, let's say, 3x over x minus 2. Okay, I just made it up. Let's just hope that that works well. Okay, we do that. We sub in a 0 and we sub in a 2 and we get 6 over 0. Okay, we can't say equal 6 over 0. We would just do that. So what does that mean? So that means that at 2, we have a vertical asymptote. So how in the world are we going to figure out the answer to this? And this is what you would do every time this happens. Every time. It's the same procedure every time. So if this happens, what I do is I think about it and I'm going to go 1/10 on either side. On either side of, in this case, of 2. All right, so we'll do some scratch work over here. So here's my 2. I'm going to look at 1.9 and 2.1. Those are the two numbers. And what I'm doing is I'm thinking about it numerically. Yes, ma'am. So a whole, for it to be a whole, I would have had to have an x minus 2, and they would have had to cross out. Crossing out gives a whole. I didn't have an x plus 2 in the numerator to cross out with the x, If I had the x minus 2 up here, then I would have crossed those out. That would be a whole. But there is no x minus 2. So if you simplify, you cross out, you get wholes. That's correct. But I didn't cross out anything. So it's basically going to be a vertical asymptote. Is that okay? Okay. So what we do is we think about this numerically. So if I put in, 3 times 1.9 over 1.9 minus 2. So this is what I'm going to be looking at. I'm just going to plug in a 1.9 up there and see if I get a positive or negative number. That's all I care about, is if I get a positive or negative number. So so this is a negative number. Okay, so I'm going to do, so that means that this thing is going like that. Coming from 1.9, it's going down. Now let's plug in a 2.1. So 3 times 2.1 over 2.1 minus 2. I'm just looking at that. I only want to know if that's a positive or negative number. That's a positive number. So that means that we're going like this. So in this case, this would be D and E, because one side goes to negative infinity and one side goes to positive infinity. So I'm going to pause there for a moment. This is probably the type that drives students the craziest. I'm not going to lie. It drives students the craziest. But I promise you, if you do exactly what I'm showing you, you go 1/10 on either side. This only happens on a type 3. Only happens on a type 3. And you go 1/10 on either side and plug it into the function and see whether you get a positive or negative number. You don't have to draw the graph like I did. I'm just trying to be perfectly clear on what's happening. Okay, and that will work. Now, just on an aside, what happens if, so let's say I have, I don't know, we'll say it's at 3. Let's say my graph goes like this. Then the limit as x goes to 3 of f of x, I'm not going to make that up. This one would tend to infinity, because on both sides it's going to infinity. So this would be an example where we would have an answer of infinity. Okay? So what about an example of an answer of negative infinity? What could you think was happening there? They're both going down on both sides. They're both going down. Then our answer would be negative infinity. That's how you get these three answers. Okay? That's how you get those three answers. Yes, ma'am. No. No, that's true. So if you get a number over 0, you're just like, well, I'm done. There's nothing I can do to it. There's nothing I can do to change the way this is going to be. I'm just done, and I need to go to my 1/10 on either side. Just done. Okay? And I understand this is probably the craziest one because there's no algebra that I'm doing. I'm just checking it out. So I just know that if I get a number over 0, there's a vertical asymptote, and I need to figure out which way it's going. Does that make sense? Okay. All right. And like I said, it's okay. That's like the hardest kind, and we'll work through any of those that we get. All right. So let's take a look at our limit laws. Limit laws are quite flexible. Limit laws are quite flexible. And they help us in several circumstances. They help us several ways. So let's just kind of look at them for a moment, and then we'll work some problems where we have to use limit laws. So we have one that's called the sum for limit laws. Notice that I am allowed to split these apart. Instead of adding these functions together, I've got here, and then taking the limit, what I could do is I could separate them and take the limit of the first one plus the limit of the second one. Sometimes that's very helpful for us if we can do it a different way, in a different order. Very helpful. Sometimes that makes our lives easier. If instead of just doing the limit of them being added together, I can do them separately. Then we have one that is the difference, and it's the same scenario. I can, instead of subtracting the functions first and then doing the limit, I can do the limit of each function and subtract the answers. Okay? We also have one called the constant multiple. What this one allows us to do is it allows us to take this constant. So are we familiar with that vocabulary word constant? So we know what that means. That's just a number, some number. A constant is a number, like, I don't know, 10. That's a constant. A constant is a number. So if we just have a number times our function, we could actually take it and pull it outside the limit and work it that way. It might be easier for us to do this. These laws are written so that it makes our work easier. That might be easier. We also have one called product. So on the product one, instead of multiplying the functions first and then doing the limit, we could actually, split them apart. We could do one limit and then the other and then multiply the result. Does everybody kind of getting the feel for what the limit laws are? Very flexible. They're very nice and flexible. This quotient one is going to be very helpful for us. And we would simply do the limit of the numerator and the limit of the denominator separately. Now this is a caution right here that they don't want us to divide by 0. That's just kind of like, yeah, mathematicians don't really like that, right? We don't like dividing by 0. That's bad. Like, I don't know, like a vortex will open up or something if you try to divide by 0. I don't know. It's bad. We don't do that. We just don't do that. We have two more to look at. We have the power. We have one that's called the power rule, where we could actually kind of think of this as taking this power and spreading it out, extending it on the result. So we're just pulling it outside the limit, and we're going to take whatever answer we get for the limit, and then we're going to apply the power. And the last one would be like a root. You could do the same thing to a root. You could pull that outside the root. Okay, so those are our limit laws. These limits of composite functions, these are more complex. We don't see very many of these, but we will see some. And the trick here, or I guess it's not a trick, the thing we need to pay attention to is that the criteria has been met. In order for these laws to work, G has to be continuous at that location A. It has to be continuous. We can't have a hole there. And F has to be continuous at that G of A, that Y value. If that's true, then we can use this scenario where we would do F of the limit. We would do the limit of G of X first, and then we would put that number in F and get our answer. The other scenario is if this limit works, the limit as X goes to A of G of X works, and F is continuous at that location, then this also works. Then we could also do this. Those are two different scenarios that would allow us to use this. Where I know you're going to be upset, we're actually not going to practice composite functions today. Bummer, right? Oh, bummer. But I just want you to be aware it's a thing, and when we get to it, we'll talk through it, okay? It's a thing. We just won't be doing that today. All right, so let's jump into some examples. I have just a few. I think I gave us a lot of room. I have 4 examples, but I just spread them out so we'd have plenty of room to write. On our first one, now here's the thing, ladies. I know in math, you're probably like I am. You're so excited to start the math that you might not read the instructions. You have to read the instructions. They're like critical. If you don't read the instructions, you're going to make a mistake. So we really need to read. When it says use limit laws to compute each limit, that means I am not allowed to just stick numbers into that and be done with it. That's not okay. Use limit laws. Okay, that's a requirement. And our requirement, our guideline, here I'm just going to show you the guideline that we use. This is our guideline. You must, and it's a must, not a can, you must show at least one limit law in your work. Okay, that's the requirement. We just went over all the limit laws. Okay, and eventually, not this time, but like next formula quiz, those are going to be on there. Like I would say, I would write this right here, and you would write this, right? The limit law. You'd write the limit law. Okay, but not for this next formula quiz. All right, so we've got to show at least one. Okay, so we've got a lot going on here. I'm actually going to go crazy. I'm going to show several. So we're going to rewrite this, say the limit as x goes to 2 of f of x minus the limit as x goes to 2 of g of x over the limit as x goes to 2 of h of x. So let you catch up with me. So the limit as x goes to 2 of f of x minus limit x goes to 2 of g of x over limit x goes to 2 of h of x. How many limit laws did I just use? 2. I used the subtraction limit law and I used the quotient limit law, right? I used 2. So great. I've used at least 1. Yay. So once you do that, we use limit laws when we have this kind of, they just throw this random information at us. They just say, oh yeah, well, limit as x goes to 2 of f of x is 4, and limit as x goes to 2 of g of x is 5, and limit as x goes to 2 of h of x is 8. We don't know anything besides those random numbers. We know nothing. That's when limit laws come in very handy. So now that I have it rewritten with my limit laws, I'm going to substitute. I'm going to take this right here. I'm going to look up here and see where it is. Limit x goes to f of x. That's this one right here. Okay, and I'm going to put a 4 in. I'm substituting. So now I'm going to look at, let's see, we're going to look at this one. We want to look the limit x goes to 2 of g of x. Limit x goes to g of x is this one right here. So I'm going to replace that with the 5. Let's look at the bottom one. I've got the limit as x goes to 2 of h of x. I'm going to replace that or substitute. Limit x goes to 2 of h of x is an 8. So the danger in this is we get so comfortable with it that some students, I know probably nobody in this room, but some students would forget to write this part. And this part is critical. Okay, you got to write that part. All right, you can't just jump to the numbers. Even though you can see what the numbers are, you cannot just jump to the numbers. You have to write that part. Does that make sense? You have to write it. Okay, so we write it. We go down there. We do our little arithmetic. Let's see, 4 minus 5 is a -1 over 8. And that's my answer. And that's our first limit laws. How are we doing? We okay? Okay. One more example, and then we'll go on to algebraic. Okay, let's see. What can we do? There's a lot of crazy going on here. I'm going to use 2 limit laws, but I'm going to do it in, well, we'll use in pieces. So I'm going to say the limit as x goes to 2. I'm going to pull that 6 out. 6 times the limit as x goes to 2 of f of x, g of x, plus the limit as x goes to 2 of h of x. That's the first thing I'm going to do. It's kind of like order of operations. I want to go inside there and pull that apart one piece at a time. So how many limit laws did I use here? 2. I used 2. I used the sum limit law and I used the constant limit law, didn't I? Okay. Is there another limit law I can use? The product. I can use the product limit law, and I'm going to go ahead and do that. I'm just going to use the product limit law as well. But I need to keep in mind that this 6 needs to be multiplied by my product. So the limit x goes to 2 of f of x times limit x goes to 2 of g of x. Okay, so that I've got that split apart plus limit x goes to 2 of h of x. So the bulk of the work really takes place with the limit laws. Once we have the limit laws nice and, spread out, we're just going to substitute. It's just a matter of substituting. All right, so we've got 6 times. Let's go up here and look to see what was limit x goes to 2 of f of x. That was 4, right? Times, let's see, limit x goes to 2 of g of x. That was 5. Plus limit x goes to 2 of h of x. What was that one? That one was 8. Hey, when this little, any of y'all have the new computer? Oh, you don't. You have the great old ones. This one just is like, I'm not going to work anymore. Oh, there, it's working. Okay. All right, it's working. So I don't know. It was vibrating in my hand. It was like, I don't know what it was doing. I'm just going to ignore that and keep moving. There we go. So we won't worry about my pen. Sorry about my problems. Sorry. So we've got, let's see, 4 times 5 is 20. So we've got 6 times 20 plus 8. Or what is that? 120 plus 8 or 128. All right. How are we with limit laws? Can we work with limit laws now, ladies? Yes? Okay, wonderful. Wonderful. All right. Are we all okay? Yes? All right, let's keep moving then. So here's what I would recommend that you do. every time that you have a limit with a fraction. This is my recommendation. If we're not doing L'Hopital, you can get away with not doing this, but I'm just saying I would just do it all the time so that I don't need to worry about remembering when I can and when I can't. Just an idea. When we have a limit of a fraction, I would always split it up into, I would use a limit law when we have a limit of a fraction, because that's going to prep us for a lesson that we'll learn later on called L'Hopital. So I'm going to do limit as x goes to -3 of x squared plus x minus 6. And then I'm going to do limit as x goes to -3, and we'll just go like that, of x plus 3. I'm just going to automatically separate them out. This will make your life easier if you just get in the habit of doing that. So when I plug in a -3, I get what? -3 squared minus 3 minus 6. That's a 0. I get, so this equals 0. This top one equals 0. And then I would do what? That equals 0. Okay, that sets us up beautifully for a L'Hopital. And I'm just going to write ourselves a note right here in case you forget why we're doing this. So we should start writing this way consistently due to future lessons. Sorry about my messy writing. Future lessons of L'Hopital. Okay, this is just, this would be a great thing if you would remember thing. Am I going to count off wrong if you don't do that? No. I mean, if you, on the L'Hopital lesson, if you don't do that, you're going to get points off. But I just, if I were you, I would just do it. Just do it. We get 0 over 0, which is an indeterminate form. So what does that mean? That means that we need to go, we need to think about, let's look at our options up here. We have 4 options: factoring, multiplying by a clever form of 1, fix a complex fraction, trig properties. Those are our big 4, right? It's going to be one of those 4 almost every single time. So let's look at this and decide. That kind of looks like I want to try factoring. What do y'all think? I think factoring looks good. Let's try factoring on this one. By the way, think about, so now I have students that like to conserve energy. You know what that means? They don't want to write very much stuff. They want to, okay, so just saying, this little guy right here, he is critical until you take the limit. You got to keep carrying him around. Don't drop him off. Don't like drop him off and say, I'm not going to write you down because that's too much work. But please just carry him along until you take the limit. Because this is like, it would be like if I have the square root of 16 and I decide that I just don't like the square root and I just want to write 16 and then work it. That's kind of what that would be like, right? Because you're just taking away, what it's telling you to do. So the limit as x goes to -3, let's see, let's factor that. Let's see, the back one is 6. It's subtraction, so we're going to do plus and minus. Let's see, what do we got? Is that a 3 and a 2? Check my work. Are we okay? Is that factoring good? So, yay, I get to do that. Now, if we were graphing this, what would that create? A hole. Now, we're not graphing it, but it would create a hole, wouldn't it? Yes, it would. So now I get to take this number and substitute it here, and I'm going to be good to go. So I put in a -3 minus 2. Let's see, what do we have? A -3. Did I factor it backwards? No, I'm goofy. I did there. A -3 minus 2 is a -5. Okay. Is that okay? Now, some of you might want to rewrite this, limit x goes to -3 of x minus 2, the simplified version, and then say -5. It really doesn't matter to me. Whichever makes you happy, that's the one I want you to do. Yes, ma'am.
I'm confused. So then why did we do like the -3 on top? Like why did we put it into like the whole like x squared plus x?
So what we have to do when we start out a limit is we have to deal with what we're given. And what we're given is this piece right here. Okay, we've got to start out with that piece. And we've got to see what happens. So if I plug in a -3 of that piece, what do I get? I get 0 over 0. And so since I got 0 over 0, that means I need to do something. That would take us to, so the three things that can happen, I got 0 over 0. I plugged it into the main thing. I got 0 over 0. That means I need to do one of these things. I need to factor or, one of these 4 things. Does that make sense? So I have to plug it into the original thing first before I know which one of these types it is. Is that okay?
How do you decide?
Which one of these 4?
Yeah.
Really, to be honest, it's kind of like guessing. What does it look? So as I look for these 4, I know it's not trig, so I can discount that 4th one. I don't have to worry about that one. I don't have a complex fraction, so I don't need to worry about that one. Complex fraction, I'll just remind you, a complex fraction would be like this. That's a complex fraction, right? That where it's like a fraction inside of a fraction, that's a mess, right? That's a complex fraction. I don't have that. So really my choice is factoring or multiplying by something. A clever form of 1. The clever form of 1 typically come with radicals. That's when we usually use this type, when it's like a square root. That's when we usually use clever form of 1. Does that help?
Yeah.
Okay. All right, so let's go back. So are we okay on number 2? All right, wonderful. Let's keep moving. We have 2 more. All right, so here we go. We ready? Yes? So limit x goes to 4, square root of x minus 3 minus 1 over limit x goes to 4, x minus 4. Okay, so let's see. So I put in a 4. Square root of 4 minus 3, that's the square root of 1. 1 minus 1 is 0. And that's 0. So I have a type 2, 0 over 0. So now I need to think, which one of those 4 things do I want to do? Does it seem like this might be a good one to factor? Not really, does it? I mean, how would we factor root x minus 3 minus 1? I mean, that would be weird. So that doesn't look like a good option. So the next one is a conjugate, multiplied by the conjugate, and it's a radical. That's what we should try. That's what we should try is the conjugate. So we have the limit x goes to 4 of the square root of x minus 3 minus 1 over x minus 4. All right, do we remember what the conjugate is? Does anyone remember that word from last year? Or the year before? Yes, it's where we split the middle sign is changed. So we do with the radical, we were working with the radical, so this is going to be square root of x minus 3 plus 1. And just keep in mind, ladies, we can only multiply by the number of 1. We cannot multiply by anything but 1. This would be called the clever form of 1. Because again, it's not an equation that we're working with, it's a limit. There's a statement. Okay, so that's what we're going to do. All right, let's do that. So we've got the limit as x goes to 4. So the beauty of the conjugate is that when we FOIL it out, the middle term goes away. Remember that? We FOIL out, the middle term goes away. So root x minus 3 times root x minus 3 is just x minus 3. Outside, inside, cancel out, so I'm not even going to multiply them together. -1 times 1 is -1. All over. Now, do not, I'm just going to tell you, some of my students love foiling. Do not FOIL out the non-conjugate piece. Do not do that, because if you do, you're going to miss the surprise. There's a surprise waiting, a great surprise. Don't do it. I know you're tempted. Don't do it. Leave it alone. So now let's do some simplifying. So x minus 3, that's x minus 4 over x minus 4 times root x minus 3 plus 1. Okay, magic happens. Gone. Now, I take this number and I substitute it right there where the x is. Now, just because I crossed out the x minus 4 over x minus 4, that doesn't mean I don't have a fraction anymore. I hope we're okay with that, right? That's still, there's a 1 up there. So I plug in the 4. I got square root of 4 minus 3. Let's see, yeah, so that's square root of 1 plus 1, so that's 2. And if you need to write out that step, please do so. If it makes more sense to you to, write out 1 over square root of 4 minus 3 plus 1. If it makes more sense to write that step out and then do your calculations, let's see, the square root of 1 plus 1, then please do whatever work makes you comfortable. Okay? How are we doing? Yes.
How do you know, when you're done? Why haven't you just plug in the x in step 4? I mean,
So the way that you know that you're done is, so what we do is we do one of the 4 things, right? We either multiply by 1 or we factor, and then we try again. We plug in that number and we try it again. If it doesn't work, we have to keep doing other stuff. We hope to get the correct thing the first time. Does that make sense? So what did we do at the beginning? At the beginning, we took this 4 and we substituted it in to see what happened. We got 0 over 0. We do our thing. This is our thing. This is what we did, right? We did that thing. Then we do it again. We take the 4, we substitute it in, see what happens. And we get a number this time. Yay. So we're done. Does that make sense? Okay. It's going to take practice. It will take practice. And then hopefully we will be good. And we'll have plenty of time to practice today. All right, last one. Let's split it up. So I've got the limit as x goes to 0 of 1 over x plus 2 minus 1/2. Limit x goes to 0 of x. Okay, so I plug in a 0 here. 1/2 minus 1/2 is 0 and 0. So I have type 2 again, x equals 0, or the limit is 0 over 0, which is an indeterminate form. So let's think about the 4 things we can try again. Do you think factoring on this problem might be helpful? No, that doesn't seem helpful at all. Multiplying by the conjugate, maybe. I don't know. I'm going to hold that off because that would be hard to multiply by a crazy looking thing like that. The third thing is, this is a complex fraction. I have a fraction inside of a fraction, so I'm going to try the fraction business first. Now, if you remember from our work in pre-cal, when we simplify a complex fraction, we need to first get one fraction over one fraction. We can't have it like that. So this is taking us back to pre-cal land, where we're going to take that 1 over x plus 2, 1/2, and we're going to get a common denominator. So that means I need to multiply this by 2 over 2. I need to multiply this by x plus 2 over x plus 2. That's my common denominator. So this is pre-cal basically. Okay? So the limit is x goes to 0. So I've got 2 over 2 times x plus 2. And I've got 1 times x plus 2 over 2 times x plus 2. I'm just cleaning it up. Okay, I'm going to pause here for just a moment, make sure we're okay.
So you're just fixing the fraction on top of
I'm going to common denominator because in order to do my keep, change, flip, I need a fraction on top of a fraction. I'm not allowed to have 2 fractions on top of 1. It has to be 1 fraction on top of 1 fraction to keep, change, flip. Okay, so I'm getting a common denominator. Now I'm going to add those things together. So the limit x goes to 0. So I've got 2 minus x plus 2, and I'm taking this fairly slow and really not skipping any steps yet. I mean, when you're comfortable with this, there's a few algebraic steps you can skip, but I'm not skipping anything right now. We are simply going to subtract those two fractions. We have common denominators. Now we can slide those together. Are we all okay? Okay. So let's just go out to the side. So this is the limit, x goes to 0. So 2 minus x is a minus x. 2 minus 2 is 0. So I have that over all over x. Is everybody okay with combining like terms? Now, the bottom denominator doesn't look like a fraction, so I'm going to stick it over 1. And the thing is, keep, change, flip. Keep the numerator, change division to multiplication, and flip the denominator. That's the way that fixing complex fractions work. So I'm rewriting. So I'm going to keep the numerator. I'm going to change the division to multiplication, and I'm going to flip the denominator. Keep, change, flip. If you are comfortable with fractions, you can see that those are going to cancel out. Now I'm going to put this here. And this is going to give me a negative 1 over 2 times 0 plus 2, or negative 1 over 4. Now, I'm going to write down here what I just did in case that's really freaking you out. This would be the simplified version of that. When I crossed out the negative x and the x, that's what it left right there. If skipping that step troubled you, this is where I would have been left. And my answer is negative 1/4.